So now what is a function? I'm going to relate this back to an equation and the table so that you kind of will see that all this time we've been talking about functions. Let's go back to what we had earlier. X plus 1 equals 2. That is an equation. From there, I said, okay, let's not just look at a single value 2, rather we could use a letter y and change the value of y so that we have multiple values on the right hand side. So if I rewrite as y, x plus 1 is equal to y, then here y is a function of x because the value of y changes as x changes. So if the x value changes, the y value is going to change. In other words, y is dependent on x. It's the same as saying y is a function of x. So we typically sort of put the y first, and we have y is equal to x plus 1. The x plus 1 part is simply f of x. We use f to indicate function. F of x simply means function of x. Now, even though this is sort of, easier to see, let's go back to something fundamental that applies to a function. It's called a relation. Now, when we say y is dependent on x, we know that y is related to x. If y depends on x, then clearly y is related to x. So a function is always a relation. But the other way, it's not true. Not every relation will be a function. So before we use numbers, I am going to sort of create a set with two, or a set where each pair is some quality rather than a number. So let's just consider beef and taco. Broccoli is veg. Salmon is fish. And we'll just do one more time. Cat, scratch. So here, beef is somehow related to tacos. Broccoli is a vegetable, salmon is fish, and cats do scratch. So each of them is a pair, and that would form a relation. So we sort of draw this graph and say beef, broccoli, salmon, and cat. Over here, we'll have, taco, veg, fish, and scratch. So beef is connected to taco. So beef is related to taco. Broccoli is related to veg. So broccoli, vegetable, salmon is related to fish. So salmon's related to is a fish. Cats do scratch. So I have related and formed a connection between the two as well. So that is a relation of a variety of things, but that corresponds to what I had over here, because that's what I considered. This is great and all, but I mentioned that I could take relation and relate it to a function. So let's go back to that y equals x plus 1 that we had earlier. So I am going to argue that we have a set of ordered pairs. So just like the pairs that I have, beef was connected to taco in some way, broccoli is a vegetable, so veg, salmon, fish, cat do scratch. So I made a connection. Those are pairs that we had. Now I have pairs of numbers and I could form a set. So for y equals x plus 1, the relation is -2, -1, -1, 0, 0, 1, 1, 2, 2, 3. And some like to call it as a set of ordered pairs. The ordered part comes from the natural ordering of the real number line. If you look at the real number line, it goes from -infinity to +infinity, but there is a proper order to it. So it has a natural ordering, which is why we call it a set of ordered pairs. I could take this and show that that function y equals x plus 1 is in fact a relation. So I'm going to write in all the x values. So -2, -1, 0, 1, and 2. The corresponding y values, I have them already. So -1, 0, 1, 2, and 3. Now, when I plugged in -2, the value was -1. So x, y. So they are related. When I plugged in -1, I got y to be 0. When I plugged in 0, I got 1. When I plugged in 1, I got 2. And when I plugged in 2, I got 3. So clearly, you can say that y equals x plus 1, which is a function So y equals x plus 1, y is a function of x, but it is also a relation. In general, a function is always a relation. In the sense, anytime we have a function, we could write a set of ordered paths, and when we draw stuff, it is going to look like this.